Hi there. Hi there. Welcome to this video on the logarithms. The logarithms. It's an interesting area of math that basically deals with exponents. Alright? Oh, and before we begin describing exactly what a logarithm is, I hope we all know our indices. And by that I hope we all know very much about numbers like 2 to the 3 or 3 squared or 4 cubed, okay? And can at least compute some of these really fast. At least you should know that 2 to the third is 8, 3 squared is 9, 4 cubed is, okay, I don't know, but I think it's like 64, yes. And so on. You should be able to work some of these things out. And I hope you also know your index rules. For example, I hope you know that a to the n times a to the m is equals to a to the n plus m. And similarly, I hope you know that a to the n over a to the m is equals to a to the n minus m. And I hope this all makes sense to you. Hope it's nothing new. And one more, this is another one, just to keep it up. A to the n to the power m should be a to the n times m. So a to the n. And I hope you know most of this, and I don't have to go over it too much. So let me clear this for a second. Alright, let's start again and see what exactly a logarithm is. But before that, let's start off by, let me give you a classic example. Let's say 2 to the 3 is 8. And we all know that because that's 2 by 2 by 2, which is 8. But in math, we've given each of these terms a name, a sort of label. And by that, let's say, I know that 8 is, let me just call it the result for now. I'm not really certain about its scientific name or mathematical name. That's the result. 2 is our base. 2 is our base. And you've probably heard that when we say you cannot, for example, 2 to the 3 times 2 to the 2 is equals 2 to the 5. And this is only possible because the bases are equal. And you notice that 2 is the same. 2 is the same, and repeated. Yeah, and we use the word base to describe that number which is being powered. The number which is being powered or raised to an index. And this right here, this number 3 here, this is the interesting bit. This is what we call our index. Or some call it the exponent. Or some call it the logarithm. The logarithm. And you'll come to see exactly what I mean. Some like to call this the logarithm. And we're going to find out what exactly the logarithm is. So like I just said, we have 2 to the 3 is 8. 2 to the 3 is equals to 8. The logarithm is nothing more than just an expression. We're just saying the same thing in a different way. And watch as I write it down right here. In fact, let me change the color and make it cooler, make it interesting. So let's say now the log, okay, the log for the logarithm, to the base 2, notice how the base is a subscript, not poor handwriting script, but a subscript, that gives me 8, okay, is 3. Now remember how I said the logarithm is 3 in this case. 3 is the power. So what this statement here in the red is saying is that the logarithm, or rather the power, which I raise my base to, the number I raise to, that gives me 8 is 3. Okay? And I know this might sound a little weird at first, you know? It might sound a little odd and hard to remember, but with practice, and with practice only, you will get extremely used to it. Just like how I know that 2 to the power 2 is 4, you will get very used to the logarithms. Trust me. All you gotta do is practice on them. So, let me give you another example. Let's say I had 5 squared. And what's 5 squared equals to? Simply 25, right? So, how am I going to express this in the logarithmic way? What I'm going to say is that the log to my base which is 5, okay, that gives me 25 is 2. So what I'm saying is the logarithm, or in this case, the index that I raise 5 to give me 25, the one I raise 5 to give me 25 is 2. It's 2. And all we're going to do right now is just work on a couple of extra examples. Let me clear this 1 second. Let me say that we had let's say we had something interesting. How about we had 8 squared? 8 squared. 8 squared would be 64. How am I going to write this or express this in a logarithm? I would say log to my base, which is 8. Okay. That gives me 64 is 2. And again, I'm going to repeat this. The logarithm, I raise my base, which is 8. The number I put 8 to the power of is 64. So basically, what I'm trying to say is, let me express it in a different way, is like saying, I have 8, okay, and I'm powering it to a certain number, okay, and that number gives me 64. So what I'm trying to say is, what exactly is this number? What I'm trying to say is, what exactly is this number? What do I raise? What's the logarithm I raise 8 to that gives me 64? What is the logarithm I raise 8 to to give me 64? And that's 2. Let me give another example. I'm hoping the point is starting to make sense. It's starting to hit home, you know. You got to just practice on them. Let's say we had 4 to the power 3, which also happens to be 64. How am I going to express it in the logarithm way? We're going to logarithm, sorry, I was mumbled up. Logarithm, the log, rather, to the base of 4, that gives me 64 is equal to 3. And I hope this is starting to make sense. I hope it is starting to make logical sense. Now I'm going to make this one a little bit different, a little trickier, maybe a little different. I'm going to say I have the number 3, okay? And there's a logarithm, it's a power I raise it to, which gives me 27. First of all, I want to see how I can express this logarithm. How am I going to express this missing number? Well, I know the log to the base of 3 that gives me 27 is a certain number. And through our indices, just like I said, I hope you know your indices. I know, well, because of my basic practice, and this is something that really gets you going. Otherwise, if you don't really know your indices, you're really going to get stuck. So I hope you practice them, okay? So I know in my mind that 3 to the third, 3 to the power 3 is 27. If you don't believe me, that's simply 3 times 3 times 3, which is 3 times 3 is 9. The 9 times the 3 is 27. So what I'm trying to say is log to the base 3 of 27 is 3. And sometimes you don't always come across such plain numbers. You don't always come across such easy numbers. Let me give you an example. I know that 10 to the power, 10 to the power of some sort, 10 to the some power is, let's say, 137. Now, when you stop to think about it, it doesn't make sense. How are you going to get this power? Where are you going to get this logarithm for? You know, the first, if I said 10 to the power 1, that would be 10, right? 10 to the power 1 is 10. 10 to the power 2 is 100. 10 to the power 3 is 1000. So I know the logarithm must lie between the 2 and the 3. The logarithm I'm looking for must lie right in between around here, 2 and the 3. And how am I going to do that? Well, if you look at your calculator, okay? If you look at your calculator, and this is probably a display. Well, I don't have a calculator with me right now, but you look for a logarithm button, okay? You'll have a logarithm button, which I'm going to try and expand up here. You'll have a logarithm button, okay? Which will probably say, read something like log to the base of maybe a of b, and or maybe log to the base x of y. Whatever it is, it's expressed like this. All you got to do is punch in that number, and what you got to write is, well, I'm going to see. How am I going to express this logarithm? How do I express it? Well, I know log to the base 10, alright? That gives me 137. I'm asking, what is a logarithm? which I raised the base 10 to. Sorry about that. What I was saying was, what do I raise 10 to give me 137? Okay? And if you plug it into your calculator, you should receive a result. You should receive a result. Okay? Now I want you to try it out for yourself for a second. Just go ahead and. So I hope you've tried it out, and I'm going to do it myself. Log to the base of 10, that gives me 137, is 2.1367. This would be 2. Oops, that would be 2.1367 to da 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 da. I'm just going to round this off to 2.137. Okay? So I know now that if I put 10 to the power 2.137, it should give me a number close to 137. Now I'm going to try it out. I'm going to put it in my calculator, raise it to the power 2.137. Alright, and please imagine I have a calculator with me. I'm sorry, the software didn't download for me right, but I'll try and work on it later. And my answer is 137.088. On and on and on. And in my opinion, this is absolutely close. This is incredibly close to 137. That's just because I rounded off my logarithm. And so that's all logarithms are. And I hope you work on a couple of these on how to express exponents into logarithms. But this is not where the logarithms stop. Just like our indices have laws and how to calculate them, logarithm, as you go in more depth, have them too. So please don't forget to practice. Thank you very much.